Hello and welcome to assignment 2 and this video, which is called The Belly of the Beast. And the reason it's called that is we're going to take a bit of a deep dive into the starter. We're calling it a monolith repository. It's probably not an actual monolith in the sense that the amount of code that's in this repo wouldn't constitute what you'd see in a monolith repo in an industry software code base, but the idea is that you guys are going to spend the next few weeks diving into some code that is already built and pre-existing. Like this is probably a bigger code base and a system that you might have worked on ever before. And it already implements some requirements, right? It implements a minimum viable product of the Dungeonmania game we've outlined in the spec. And you're going to have to go in and get used to working with this code to understanding to an extent. You don't have to understand all of it, but understand enough to be able to make changes, to make improvements and refactor the code and to analyze the design. So this video is basically just designed to give you a bit of an orientation as to what's going on. You'll have to do a lot of figuring out yourselves with you and your partner to just understand a lot of the particular intricate mechanics, particularly in making changes. But what I'm going to do is very quickly run through what's in this repo and then implement a feature to kind of show you how you might go about investigating and making changes and some tips and tricks for using VS Code, which hopefully should help you as well. So I'm going to start with a very quick code tour. A lot of these are generated get ignored files you don't have to worry about, but going from top to bottom, we have the client folder. That contains all of the front-end code, which for the most part, you don't need to touch or worry about. It's there if you're interested to look at. It's written in TypeScript. We don't expect you to have to deal with this at all. But if you are doing the dungeon generation extension, dungeon generation task part of task 2, then you'll have to add some stuff into this front-end code. You don't have to do it. It's up to you, but it's interesting if you like JavaScript. So that's the client folder. And then other than the source folder, which I'll go through in a second, we just have stuff that probably most of you are pretty familiar with, the git ignore, a GitLab CI file, which sets up the continuous integration pipeline, the green tick that you get in all of your repos. The Gradle configuration file, I might talk about this a bit more later. You've been using it since Lab 3, and I'll briefly explain sort of what the different parts mean. And it's not something you need to really know for this assignment, but some of you might be interested, and it's good to understand just at a very high level what's going on, and it's not just this sort of black box file which you never touch and have no understanding of ever. This check style is what sets up the rules for the linter, which you've been using for assignment 1. This is a template for the configuration values, which is described in detail in section or part 3 of the spec. And these are all essentially the values, the constants that are embedded into the model when the program is run, which you can tweak and change as you'd like to make different gains. This is the coverage script. It just gives a little coverage output on your repos. And then it's obviously the README. So that's code tour. Now, I'm not going to go through all of the stuff inside the source folder because there's just heaps of files and there's no use in me sort of going through and explaining every single file. Instead, we're going to implement a new entity in the current game. You don't yourselves have to do this. This is just an example of how you might make a change. And we're going to implement armor. So if you think about the game at the moment, I might even just run it to show you. So if you go to app.java, this is, again, same as the assignment. You've got all the scintilla stuff here, which sets up a little web server that you can run locally. And this app.java contains the API layer. So you think back to 1531, it's like your Flask or your Express server wrapper around the controller. Same thing. There's a couple of extensions. Sorry, I keep saying extensions. A couple of tasks which you can choose to do in task. I think it's task 2B, which will mean you have to modify app.java and add in some more endpoints, but it's pretty straightforward and you can look at the existing stuff there. Anyway, so this is how I run it locally, and you can see you specify a dungeon and configuration file. This one's probably the wrong one, actually. I go to build a shield. What I want to be able to do is pick up entities, which we can do in the starter game. Sorry, I've still got some breakpoints here. Bit of a spoiler for what we'll see in a second. Okay, localhost, rerun that. So all I want to be able to do with this armor entity is just pick up the armor and have it added to the inventory like we do with the arrows and the wood and some of the other collectible entities. Very straightforward. So I'm going to stop that. And normally when you implement something new, you start by analyzing the requirements, right? You look at the spec, you maybe do some highlighting, get your highlighters out, figure out what the entities are, figure out what the problem is, do a bit of articulation, maybe ask some questions if you need to, and then come up with the design. For this one, because we're going to do a lot of sort of exploring, we're not going to come up with a design up front necessarily, but once you're more familiar with the code base, and by task 2, when you're actually implementing new stuff, hopefully you are, you'll be able to say, okay, well, here's what files I'm going to change, here's the classes, here's the fields I'm going to add or remove, or whatever the case may be. So you'll do your design, and then the next step is to write a failing unit test. And the next step is to write your list of tests, and we're just going to write one test today, which says, can I pick up armor? That's our test list, and then we'll actually write the failing tests. So this is all the source code inside source main Java, and you're pretty familiar with this by now. Same structure as for assignment 1 and all the labs. But if we look at the tests, here are all our tests for the existing functionality. What I'm going to do is make a new file. Actually, I'll make a new folder as well inside Dungeonmania. I'm going to call it v2. And inside v2, I'll make armor test.java. Cool, here's our test class, and it's going to be very simple. We just want to be able to pick up the armor. It doesn't do anything. It doesn't give us defense or anything like that. So we can look at any of the other collectible entities like keys. And I'm going to copy this. I'm just going to copy this test and paste it into here. And then just import everything. Get rid of that. Import dungeon response. Now, I've prepared 2 files. Other than these 2 files, the code is the exact same as what you and your partner will be given in your repo. I've just written up a configuration file for the dungeon and the actual dungeon itself, which specifies I've got a player, I've got an armor entity and an exit, and the goal is an exit. Pretty straightforward. And this will be used in our test. So I'm just going to go to our test and change this to D armor and change this to C armor. And the new game function will go and load up these JSON files and say, well, this is now our dungeon map and this is our configuration. Need to import test utils as well. And I'm just going to change, well, import assert equals. And I'm going to change key to be armor, like so. Other than that, completely the same test, very straightforward. Cool. Now, if I run this, it should fail, right? Because we haven't actually implemented armor yet. And I run it, and lo and behold, it does fail. Now, because we don't really have any understanding of the code base yet, and one thing I'll say is that, as you can probably tell, I've prepared this. I already did a take and decided to redo it. But other than that, I didn't actually write this code. It was written by 3 of our great tutors, Webster and Tina and Artie, and they've designed which really architecturally quite a well-written system. We've put in some smells and some places where you can improve the design, but at a very sort of architectural level, it's very well designed. And as part of that, as in part of preparing for this, I've had to go and understand a bit about what's going on and get familiar with the code. And that's a process that you'll have to go through as well. We're very keen for this assignment to give you skills in understanding code that you haven't written and being able to go and analyze it, look at the design, as well as being able to make changes. Anyway, So let's figure out where we can start, right? Because we don't really know much about the code. All we have at the moment is a failing unit test. But really that's all we need, right? Because you can see here, we've got this java.lang.null pointer exception. And so there's some stuff here, blah, 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 build map, game builder. Okay, well, maybe let's go to game builder and see if we can figure out what the error is and slowly start to build that functionality just by going and following the trail of breadcrumbs. So inside Java, inside source main, we'll go to Dungeonmania and game builder, which is inside here. Cool. If we go to 82, here's our line. All right, entity. We've got a new node variable. We call the getEntities method and we call get0. Now, I can do some speculation as to sort of what's going on here, some sort of reasoning, but probably the easiest thing to do for now is just stick in a breakpoint and run it again. Cool. Let's go and see new node. Now that looks fine. One thing to watch out for is we're inside this for each method. So maybe we are looking at the wrong iteration of the loop. The only reason I say that is because what it's going to do is load up each of the entities in the JSON array and look at them one at a time. So we're probably still actually looking at the player. We can verify that just by going back to game builder and stepping through one line at a time. I can have a look in here and see, not this, sorry. See that we're actually looking at the player entity. So then maybe let's skip forward to the next iteration of the loop. And you can see that now we're on the armor. Okay, let's have a look at this. New node is null. All right, so that's probably our problem, right? Here's why we're getting a null pointer exception. Okay, next question, why is new node null? Okay, let's have a look. Graph node factory.create entity. So this is returning null when it shouldn't. Let's have a look in here. What we can do, rather than like going back to the panel and searching for the file and trying to figure out where it is, we can actually go right click and go to definition, and that'll take us straight there. So this factory class, and we can immediately see there's a whole list of entities that are kind of currently supported by the system. And because we haven't introduced armor yet, it's not on there, which means we should probably put a case statement here. Case armor, a little colon. There we go. Okay, so now that's supported, and it'll return this graph node like it does for every other entity. That's good. Let's stop it and rerun. So that'll be processing the player. Now it's processing the armor, and you can see that now we have a different problem, right? Like we didn't even hit this breakpoint the second time. We're still somewhere else. Gamebuilder.java line 81. Okay, so we got as far as here, and then something went wrong in this method. Dungeonmania.map.graphNode init. Init is just the constructor. So inside the constructor of graphNode, something went wrong. Okay, let's have a look there. GraphNode. Okay, so that's these lines here. And then you think, well, okay, there's this entity, and we call entity.getPosition. And what have we got? Okay, null pointer exception. That probably means that the entity is null. Okay, the problem's not here then, right? The problem's somewhere else. And you've probably all encountered this before where, you know, as a process of debugging and as figuring out what's going on, you have to kind of go down this rabbit hole or follow the trail of breadcrumbs. And that's essentially what we're doing here. And as we do that, it'll help us understand the code and how it works. So what I'm going to do is right click and go to references, which says anywhere in the code that references this line, or says, you know, I'm going to call this constructor, tell me where it is. And you can see this is really useful because then we can see any place that uses this function. And what we noticed is it takes us back to the graph node factory, which we were just at before. And you think, okay, what about this factory.create entity? What's happening there? Maybe this is null, right? If null is being passed into the constructor, this function is returning null. Again, let's verify that with a breakpoint. Never, like one piece of advice I give is when it comes to just debugging generally is never make assumptions about what values are. Always put in breakpoints, always check your assumptions. Because if you kind of go along making assumptions and then, like maybe 50% of the time you'll be correct, or 80, 80, 90% if you're good at what you're doing. And, there's always a margin of error, right? And it's better to catch that early than to kind of work on an assumption for a while that turns out to be wrong, and then you've kind of wasted all this time. Anyway, so we're at new node. Let's go to the next breakpoint. Okay, we're here. I'm just going to copy and paste this into the debug console. Again, another really handy feature of VS Code. You can evaluate particular expressions at runtime while you're running the code. So this returns a player, and you think, well, that makes sense because we're still processing the player. So I'm actually going to hit play again. And again, okay, so now we should be processing the armor. Yeah, see, armor. Cool, okay, hit play again. So now we should be trying to say, well, what is the armor? And you can see this returns null, all right? We validated that assumption. So now let's have a look inside create entity and see what's going on. And this here is a factory pattern, which we're going to talk about properly in week 7. You don't have to implement this, but it is good to understand sort of what's going on and say, well, okay, well, here's all these methods that have something to do with creating entities, and that's what factory patterns do. But for this particular problem we're trying to diagnose here, so this is returning null when it shouldn't. Let's go to construct entity, see what's happening. And you think, oh, okay, again, we've got a list of supported entities. And you think this also makes sense, right? Because we're creating a new arrow, new wood, new treasure. Somewhere along the line, we're going to have to make an armor class and create a new instance of that armor class when we create the entity. So it's the pieces start to kind of fit together as you go, okay, well, this is where the map is constructed at the beginning of the game. So all we kind of need to do, I guess, is say, well, add another case here, armor. And we're going to return, we're just going to return null for now, but in a second, let's go and change this because we're going to go make an armor class. I'll just stop the test for now and go to collectibles. Armor is just a collectible entity. And I'm going to make a new file called armor.java. Now, immediately you might think, oh, what classes do I have to extend? What interfaces do I have to implement? And you could probably figure out just by looking at this. We're going to extend the entity class, and we'll probably need to do this at some point as well. But for now, let's just sort of do it as minimally as we can and build up from there and work through errors as we go. These classes are pretty small, as you'll notice, right? A lot of these methods aren't even used. That might be a code smell. Think about that for task 1. And for now, we don't really need to think about functionality inside the armor class. We just need to say, here's this entity armor. We'll worry about what exactly it does later. For now, we'll just say armor extends entity. So import that class. And again, oops. Add the unimplemented methods, add the constructor. Cool, let's just leave it like that. We can clean it up later. We can figure out what's going to happen in these methods later. Let's go back to our factory and then say return new armor. And we're just going to pass in the position. If we, again, F12, I think it is on Mac. We just go to the definition for this constructor, you see it takes in a position. So that all lines up, that all makes sense. Cool, now the code should work, right? The test should pass. Not sure about that one, but we'll see if we can get through a few lines of this, right? Can we create a piece of armor on the dungeon map without failing? Let's put a breakpoint here and run the test. And now I need to get rid of all my other breakpoints. Often you want to keep these in. Sometimes you can actually mute breakpoints as well. You go disable breakpoint, which is really helpful when, oh, sorry, maybe you can't mute breakpoints in VS Code. I thought you could. We'll untick this one. That's right, you can mute them by unticking them. Because sometimes you want to return back to them for later. But I'm just going to skip through them now. So we've done all the node creation and test still fails. Expected 1, but was 0. Okay. That should be fine. I think I may have, oh, I disabled this breakpoint as well. Sorry. Let's run that again. Yep, skip, 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 keep going. And you can see we actually got here, right? So we got through the first 3 lines. We create a new Dungeonmania controller and then create a new game. So we know that armor is being made on the map. That's a good start. All right, the next step is, well, let's see if these assertions pass. So I'm just going to say step over to the next line. And you can see that passes. So armor is actually being made on the map. It's getting picked up. Sorry, not picked up. It's being detected by the entity response in the dungeon. And we tick right. That all goes fine. And you can see now here's where things go wrong. And we start to get into code that we haven't written. This is pre-compiled Java that's part of the testing infrastructure. But essentially, we know that we've kind of hit a dead end, right? So let's look at the next error message. Assertion failed, expected 1, but was 0. So we got to here and said, well, I expected you to have 1 armor in the inventory, but you didn't have any, you had 0. I think, okay, well, that makes sense. We haven't actually written picking up of armor yet. So how do we do that? Well, we don't really have a failing test that we can just, well, we do have a failing test, but we don't have like an exception or something we can investigate. So maybe let's look into this code here and try to figure out what's going on. So we look at get inventory, and that does all the stream stuff, and it checks what it starts with and makes a list. Okay, maybe let's look at the res.getInventory. And now we've moved from, you notice we were in the testing utils file before, which is part of the testing code. Now we're inside the response. This is like your file info response or entity info response from assignment 1. It's the same thing where, like JSON in lab 2 with the hotel, it's a way for the model to communicate with the tests or the front end or some external client, right? It's a method of data transfer. In this case, it's just a struct, right? It's like a Java class that doesn't have any functionality. It's all just fields that are sitting there. And so you go, well, okay, the inventory is being passed through the response. That makes sense. Where is the response being constructed? Okay, well, let's go to the constructor and see where this is defined. Okay, we've just got an overload here. We go to the constructor again and say, well, this is where the response is created as part of the model, right? This is that now we're actually inside the backend, not just part of the response or the test code. We're inside this response builder class. Again, another creational pattern, which has the job of constructing these response objects. You think, well, okay, cool. It creates this response. And where does it get the inventory? We've got this get inventory response here. That's probably useful to know. So let's see what happens. Okay, we get this inventory parameter here. Okay, that's passed in through game.getPlayer.getInventory. All right, let's go to that. And again, we kind of just keep going further and further down the rabbit hole. So there's this inventory attribute here, which belongs to the player. Yeah, that makes sense. We look inside the inventory class and we can add stuff, we can remove stuff, we can get a list of buildables. Okay, lots of other stuff going on here. Okay, well, we want to add something to the inventory. Maybe let's have a look and right click and go to references. Oh, VS Code's taking some time. Okay, interesting. It's used in the player when we build stuff. That's probably to do with buildable entities, so not exactly what we're looking for. And then we also have this method pick up. Okay, well, we want to be able to pick up an entity, right? So that might be useful. Let's have a look at that. Public Boolean pickup. Okay. Now, where is this called? Let's have a look. Again, go to references. Oh, interesting. Okay, so it's called in arrow, in bomb, in key, all of our collectible entities. You can see that some variation of this code is called. So let's look at something like maybe arrow, because it's quite similar, very, very simple entity. Inside the onOverlap method, which takes in a game map and an entity, checks if the entity is an instance of a player, and then picks it up. Okay. Because arrows, as we showed on the front end, are quite similar to armor in this way, we might just kind of copy this. It doesn't have to be great design to begin with. We just want to get something working. So let's copy this over to armor and paste into onOverlap. Just need to import some stuff. Cool. All right. Now let's see if that works. Go back to armor test, take this breakpoint out and run again. I'm just going to take all these breakpoints out so that we don't have to go through them each time. Expected 1, but was 0, blah, blah, blah. So we haven't solved it yet. Do we save the file? Okay. So that didn't fix it. All right, maybe that wasn't the right route to go down. Let's now have a look at tick, because the actual picking up gets done in the tick. So if we want to debug, we probably should actually look at this method here. There's a lot of stuff going on, so this might take a while, but if we look inside tick and start to kind of dissect what's going on. So now we're inside the Dungeonmania controller, which is the interface file, and you see that there's not a lot of stuff going on here because the model handles most of the functionality. And this is really just this really is just the interface between the client, which is the test at the front end, and what's going on sort of deep in the monolith. So we saw that response builder class earlier, and that just says, get me a dungeon response for this, okay, game.tick. That's probably pretty important. Let's have a look at that. Now, this brings us to some quite architectural stuff, and this is going to what I was saying before about this system actually is quite well designed at a very sort of foundational level. There's some smells and stuff that you'll be fixing as part of the assignment, but the way this works structurally is quite interesting. And it relies on a few ideas in the functional paradigm, which we've talked a bit about before, and you'll get to really get hands-on with in this assignment. And a few sort of ideas around event-driven programming as well, which we'll continue to explore a lot. So at a very abstract level, how this implementation of the game works is if you look at the tick diagram inside, I think it's part 1 of the spec at the very bottom, it says, here's everything that happens in a tick. How this solution implements that is it says, well, we're going to call each thing that happens in a tick an event. And what we're going to do is we're going to queue up all these events to happen. We say, okay, this is going to happen, and this is going to happen, and this is going to happen. We don't actually do anything yet. We just make this queue of events. And then what we do is we go through the queue and play out the events. This is an idea in event-driven programming. We'll talk about it a lot more later in the course. But for now, what you need to sort of, I guess, understand with the code here is that that's what's going on with this priority queue, this sub and adding sub, which maybe at a surface level don't initially kind of hit home. And these register methods, what they do is they say, I'm going to add an event onto the queue. And an event in this case is a function, right? This is an anonymous function, which we are setting up, but we're not actually calling. So when we run through this tick method, it goes, okay, line 55 and then line 56, the code here, the player.move, doesn't actually run yet, right? It's all wrapped up inside a function that someone later is going to go and call. And we'll see how that's done. So this, just to look inside this register once method, it gets given a runnable. This is a function, right? And again, this goes back to functional paradigm, functions as first class values, or functions in Java as objects. And it gets added to this, essentially a priority queue as a comparable callback, which is a class that we've defined. If you've done any sort of web programming before or JavaScript, you might be familiar with the idea of a callback. It's essentially just like if you have let's say you had a web page, right? Or you're loading a web page, and then you run a function once the web page is loaded. That function that you've just run is called a callback because it says, Okay, well, once you've done this thing, go back and call this function, which I told you to run in the beginning, as a sort of queue of events that take place. That's I guess, a very short explanation of what a callback is. And it's used very frequently in web programming, and it's used here in the way we handle events. We say, queue up these events and call them back one at a time. You don't have to worry too much about exactly how this class is implemented, but just for your information, this is where the callback actually gets run, the code actually gets executed. And then the rest of this is just allowing your callbacks to be compared as to which one of these is going to be run first. Because as we saw somewhere that I've lost track of, I go to references. Yeah, if you go to game, this is all in a priority queue. Anyway, that's a bit of a side note as to how the behavior of tick works and is implemented architecturally. But what we do here is we say, okay, I'm going to register this event, this line of code to take place at some point. And what this is going to do is move the player, right? Player.move, this.getMap, blah, blah, blah. This just says move the player in a certain direction. So let's have a look inside here. And I'm going to stick a breakpoint at map.move2, because when we move on to this location, we want to pick up this item. That's the kind of fundamental idea. And you see that we added the code into Armor to pick up the entity, but something went wrong. So again, we're sort of approaching it from two fronts, if you like. And that's how a lot of sort of, again, understanding code that you haven't necessarily worked with before can be done. You can we push on multiple threads and figure out which one leads somewhere. So, okay, I'm going to run this again. Now we hit the breakpoint. And what I'm going to do now is step through sort of line by line to see what's exactly happening. So I'm going to step into here. This is a lot of kind of position stuff, which you don't need to worry about. You see that it's calling translate by, which says what's the offset, where am I actually traveling to, how many squares. And then we get into, okay, now this is all done, right? That's what we've just moved into. And now we move into the move to method. Sorry, that's exceptionally confusing. But here we are, public move to entity position. And if not can move to entity position, then we return, right? If, this might be like if the player tries to move into a wall, then nothing happens. And we'll hit step over again. And what we notice is that we immediately return out of the function. Okay, what does that tell us? Well, probably that can move to is returning false. So I'm going to stop and run it again. And I'm going to go into move to and put a breakpoint here. So we'll skip to the next breakpoint. And just to check my assumption, I'm going to copy this, paste it into here. And lo and behold, that is false. Okay, now why is it false? We can figure that out as well. Let's go to definition and put a breakpoint here. So we skip to that. Nodes.contains key position. Now, even I don't know exactly what this means, so let's just see what it is. Okay, well, it's true. I'm not exactly sure what this means, but let's look at the next part of the statement. And that also evaluates to false. Now, I'm not exactly sure what this part means here, but if we look at the second part, you think, well, okay, nodes.getPosition can move on to. That's saying, as a player, can I move on to this wall? The answer is no. As a player, can I move on to the switch? The answer is yes. Or can I move on to a potion and pick it up? Yes. So maybe there's something to do with this method can move on to. Let's have a look at that. And I'm going to stick a breakpoint here as well. All right, so entities.size equals 0 or entities.stream.allMatch can move on to. So what it says is, well, either there's nothing on this square, or if I look at all the entities that are on this square, can the player move on to all of those, right? Like if you have a spider and a player, the player can move on to the spider. Sorry, if you have a wall and a spider on the same square, the player can move on to the spider, but not the wall. So they can't move on to that square. Whereas if you have a spider and some collectible entity, then the player can move on to both, so they're allowed to move on to that square. Now, again, let's have a look. Well, this is going to be false, right? Because the armor is sitting on the square we want to go to. So what about this one? This is also false. All right. E dot can move on to. Let's copy into that. And we notice public Boolean can move on to. Interesting. That's defined in entity, and we just return false. If we go to armor, maybe we think, well, let's override this method and just return true. And we'll see if that's done anywhere else. Can I go to references? No, I don't know if I can go to implementations. Yeah, here we go. So every single subclass that overrides this method will have a particular implementation, and you can see that exit you can move on to. Door you can move on to depending on whether the player has a key or whether the other entity is a spider. So you think, oh, well, let's say at override, public void can move on to, sorry, public Boolean can move on to. Oops, and that's done it all for us. Return true. Okay, let's see if that fixed the bug. Run again. And we'll have to skip through all of our breakpoints. Interesting. Okay, so we got a different error. That's always good. Class cast exception. Collectibles.armor cannot be classed to entities.inventory.inventory item. Okay. Interesting. Let's go player.pickup line 88. Player.java. Return inventory.add. And we saw this before, didn't we, right? The player picks up an inventory item, and we have to do a cast here, which probably should have some sort of check on it. But we do an unchecked cast, which is why this exception gets raised here, is because at the moment, armor isn't an inventory item. And to fix that, we should do what we said we would do before. So I'm going to say implements inventory item. And we don't have to do anything else. We don't have to implement any extra methods. So let's run it again. Uncheck that. Keep going. Just going to take out all the breakpoints. And the test passes. Cool. So have we got it working? Well, I'm not 100% sure. We got the test passing, which is always good. Let's check that our code actually does work by doing a usability test. And so we are kind of going through this process of what we call the task lifecycle, where you kind of do your whole software development lifecycle, but just on the scale of one task, like armor in this case. So I'm now going to run the front end again. Go to app.java. Oops. And hit run. Just go back here and reload. So now I'm going to load it up with the same files I used in the test. Now, one thing you'll notice is that they don't actually show up here, and neither do the 50 billion config and test dungeons that were in this panel a second ago. You think, well, why don't all these files that are breaking my VS Code show up? The answer to that is because there are two ways Gradle resources are configured. And this is probably where I'll talk through the Gradle file now. So if you have a look here, source sets, what this says is, tell me where the code is and tell me where all your resources are. And so Gradle can figure out what lives where and where to essentially configure everything. And VS Code reads this as well. This is kind of your build chain, your build, sorry, what it's called? Essentially your build management. Other languages like C++ use a sort of CMake. It's like, you can think of it a little bit like a make file in C. Anyway, so we have two types, main and test, right? So main is when you run app.java, when you run your actual application, and then test is everything that relates to your tests. So the test code is in source test Java, the main code, the actual source code is in source main Java. And all resources that are accessible to the tests go inside test resources, whereas all the resources applicable to the actual application when you're running it are inside main resources. So this is why when I run the tests on JUnit, the tests they can detect the dungeon. If I go Gradle test, which this is also good to do just generally, just to make sure all your tests are passing locally before you push to the CI. This will take a while because it's got 100 something tests to run. Testing. Oh yeah, 99 tests. Cool. That checks everything works, and you can see our armor test is added there as well. This has access to everything that's in test resources, which is on the left here. But we want our stuff to be accessible inside main resources so we can run it on the front end, which means all I need to do is copy this and look at resources, dungeons, and copy that into here. Sorry, I've copied it into the wrong spot. Go inside the configs. Config armor. And this one's dungeon. Cool. So now let's go through and run that on the front end again. New game. We'll call it D armor and C armor. And you can see that the armor entity is actually pre-loaded because we have it in an old version of this assignment. Now, one other thing is that if you've got breakpoints in VS Code while you actually run the application, or actually, I think it's only if you run in debug mode, which my VS Code doesn't have set up properly, but essentially, if you can actually debug on the front end as you go, so you can hit the keys and play the game, and then put in breakpoints to stop the code. That's really useful, particularly when it comes to finding errors, so that you can then write a failing unit test and go through all that process to fix your bugs. I'm just going to go through and take all these breakpoints out. There we go. Cool. So now I can pick up the armor entity. That all works fine. Cool. Okay, so now I'm going to go through the process of pushing changes and the process that you and your partner will need to go through whenever you make a merge request. So in terms of committing stuff, you're obviously welcome to use command line. That's my preferred method, to be honest. But you can also do it through the IDE interface. VS Code gives one here, where you can see all the changes that you've made to all the files. You can see that this is the files I added. These are the lines of code that I added, removed. You can see we added one here. That's really useful just to get changes, particularly when there's lots of code you're working with and there's some things you might accidentally change and don't want to make, and you want to make sure that everything that goes into your merge request is changes that you are wanting to merge into master and not some accidental stuff. So once you've figured out what you're going to put in your commit, inside here, we can just write a simple commit message like implemented armor or implemented and tested armor. And then I should be able to commit that. It'll say no stage changes. This is like, your git add basically. I'm going to say, yes, please do that for me. And now if we go git log, you'll see that it's added another commit with all our changes. And now I can sync up, which should, I believe, push to master. If I go git push again, oh no, it hasn't done that yet for me. Sorry. I'm going to say push to, and then origin. And that should, in the background, do a git push for me. Nope, it doesn't. Never mind. I'm not super familiar with the VS Code interface, to be honest, but anyway, that does it for me. Oh no, so everything up to date. Weird. So now, once we've pushed our changes, we're going to go to GitLab and look at master, which has got a green tick, and let's make a merge request. You've probably done this heaps of times before, but it's just worth highlighting again. And we'll make sure we're merging into the right repo. It's worth highlighting, make sure that all your changes are relevant. So if you're including unnecessary stuff, whether it's like, you accidentally worked on two things in the same branch, any other unnecessary changes, make sure you take them out. You want your merge requests to be easy to review. You want your partner to have to do as little work as possible. And it also comes down to making merge requests small, which is another big thing I see students and even people in industry do a lot, is they make their merge request really huge and they spend 3 weeks working on it and it's all these changes. And you have this very big, long sort of iteration cycle. Whereas if you keep it shorter, you can merge more stuff in, it's easy to review, and you do it one at a time. And this kind of harkens back to the incremental design stuff we talked about in the Monday lecture. Anyway, here's all my changes. I'm having a look at that. That looks good. I'm happy for all this stuff to go in. Realistically, I'd probably want to fix all this stuff here, probably clean up these comments. But anyway, let's just do it. And we won't delete the source branch, and we will squash the commits. And I'm just going to say armor and create merge request. Now this will run a pipeline. I'm not sure why this pipeline is not working. Oh, the linter is probably, the linter is complaining to us because we haven't fixed, there's some problems in the armor. And pretend we fix those, I guess. And then, oops, create merge request. No, I've already done that. So now we look at this, and you will also want a list of changes, right? I see a description of the changes made. Often this will just link to an existing design. But for this, I'll just say implemented armor, usability tested on local frontend, wrote unit test for collecting armor. Typically, a lot of you'll just need to link to your design documentation and say, well, here's my design for the armor, here's my test list, depending on how kind of complex the piece of work is. But someone reviewing this can say, okay, well, here's all the changes, and go through and make comments. Maybe they decide that this particular is redundant comment, and you'll have a ongoing discussion with your partner, do your PR reviews. Once that's done, everyone's happy. The PR gets approved, not by the person who wrote it, and then hit merge. Obviously, you'll need a passing pipeline. Just doing this because I don't have time to fix up the linter stuff. And that's it. So I hope this video is helpful, probably a bit longer than I expected, but hopefully it gives you a bit of insight into just how to work with this code base and how to deal with lots of unknowns and dive in and just try and figure stuff out. We're very keen to see how you go with this. Please always reach out if you need help. There's a forum, there's help sessions, shoots and labs. We are here for you, and we hope you have a lot of fun. Thanks.